Hello and welcome to today's webinar on the Jameson Concentrator. While Glencore technology has designs and manufactures a range of mineral processing and smelting, refining and leaching technologies, today we want to talk about our new and exciting Jameson Concentrator. And this webinar today will basically looking at an overview of how that works. It'll explain how the Jameson Concentrator delivers the concentrate, but also for less energy, cost, and also a much smaller footprint. Our presenter today will be Dr. Gabor Czajkowski. Gabor is a principal metallurgist at Glencore Technology. He holds a Master of Science and a PhD in metallurgy with over 15 years of experience in every avenue of metallurgy, from research development all the way up to numerous operations. Gabor has published several technical papers in peer-reviewed journals and has delivered many presentations globally. As you listen through the presentation today, please feel free to answer or post any questions in the Q&A button you'll see at the middle of your screen at the bottom. We will attempt to try and answer those questions during the presentation, and if we don't quite get to all the questions, we will certainly get back to you with those answers shortly after the presentation. Another principal metallurgist, Adam Price, will be joining myself at the conclusion of the presentation, and we will go through a 15-minute Q&A session. There is no need to take notes. This webinar will be recorded, and if you are registered, which you hopefully all are, we will post a link to that recording so you can go back and have a look at some of those things you may have missed during the presentation. Towards the back end of Gabor's presentation, we will also be posting a short 5-question poll. This is can be anonymous. It's a multi-choice. This really just helps us to learn some of the content we're doing and try and improve for the next webinar to ensure that we answer the things that you guys want to hear. Lastly, if you have any additional questions, please feel free to send them to the website. You can the email link at the bottom left-hand of the screen. And otherwise, thank you very much for attending, and I will now hand you across to Gabor.
Thank you, Glenn. So the title of my webinar today is Jameson Concentrator, Energy Efficiency with a Reduced Footprint. So my presentation will cover the following key topics today. First, a few words about Glencore technology, then some industry trends, conventional concentrators, and what the issues that we see with conventional concentrators. Then obviously the main topic, the Jameson Concentrator, some projects that we have been involved, and our assistance, GT's assistance across different project phases, and then just to wrap up my presentation. Firstly, just a bit about us. Glencore Technology sits within the large Glencore group and is made up of around 140 employees. We're leaders in innovative technologies that have serviced the mining industry for decades, and we operate within the most commodities. We supply a unique set of high-value technology solutions to our partners globally, with technology transfer available in our operations, our technologies. And our technologies were developed to solve real operational problems. GT offers the following technologies: ISOMIL, Jameson Concentrator, Jameson Cell, and some hydro and pyro technologies such as the Albion process, ISOSMELT, and ISOKID. In today's webinar, I'll be talking about the Jameson Concentrator, which consists of Jameson cells and ISOMIL for regrind purposes. Before I jump into the technical part of my presentation, I would like to highlight trends and actual challenges of the mining industry. There are 5 trends I would like to discuss. 1, cyclical commodity prices almost always force miners to plan for higher throughput. Similarly, 2nd, declining ore grades, as shown on the graph, require ever larger concentrators to achieve economies of scale. The 3rd, more finely dispersed minerals normally represent recovery challenges for flotation. The other one is the fourth is the suboptimal project execution, which can be normally observed and can be contributed to the badly timed investment decisions and habitual plan designs. And finally, the fifth is the energy efficiency. To minimize carbon footprint have become crucial and critical as part of the increasing ESG pressure on miners. So, issues with conventional concentrators. The design of traditional circuits are based on residence time to compensate for the lower flotation rate constant in mechanical cells. In addition, the lack of froth washing and lower carrying capacity of mechanical cells require multiple stages of cleaning. These factors all add up to the huge footprint needs of mechanical cells. Due to the large footprint and height requirements, high structural and building costs are associated with conventional concentrators. There are also extra capital and operating cost implications of blowers and mixing mechanisms used with mechanical cells, not to mention the increased heating costs of indoor concentrator buildings because of the larger footprint. The response of tank cell suppliers to accommodate high throughputs has been the volume increase of mechanical cells to over 600 cubic meters. However, froth transport distance and efficient mixing can be the challenges on this scale, aside from the previously discussed CapEx and OpEx implications. So what is a Jameson concentrator? The Jameson concentrator comprises of high intensity and low footprint Jameson cells for all flotation duties and our well-established horizontal regrind mill, the isomill. The Jameson concentrator offers a compact, high-capacity design which enables operators to reduce footprint by 40 to 60% and achieve over 30% savings in CapEx. Beside the CapEx benefits, the Jameson concentrator can provide over 45% reduction in OpEx, flexible flow sheet configurations, and modular designs. So where are all these benefits are originating from? On the one hand, it comes back to the small air bubbles generated in the Jameson downcomer. The Jameson cell produces very fine bubbles in the downcomer. See just the graph above, the red line, and that contacts 100% of the fresh feed, which guarantees rapid and extensive particle bubble interaction and hence fast flotation kinetics, resulting in smaller cell sizes for every flotation duty. On the other hand, the use of wash water and increased carrying capacity in Jameson cells compared to that in mechanical cells enable operators to typically achieve an upgrade ratio equivalent to 3 stages of mechanical cleaning with 1 stage of Jameson cell. As for managing high tonnage and throughput, now we have the new B and Z 8500 12 downcomer Jameson cell that can treat up to 1500 tons per hour through a single unit. Z8500s were successfully installed at Cadia, and 7 B8500 units are in a delivery for a new project. Talking about new developments, we are now offering the new armless design for all B cells to save on height. This picture is just an example of the B8500 12 downcomer cell, which is the biggest one in our product portfolio. And on the middle, you can see the external recycle mechanism on the right side, and that recycle mechanism can be completely removed and and with a dual outlet configuration, the whole unit can be lowered. And with this B8500 unit, you can actually reduce up to 7 meters in height. And we all know what height means in terms of costs. As discussed earlier, GT can also offer isomill for regrind purposes. Isomills have a long history in the industry. The first large-scale isomill at 1.1 megawatt capacity was developed by Strata and Natch in cooperation. And the first isomill in commercial operation was introduced at MIM, Mount Isa, in '94. That enabled some technology to find its feet in McHart River Mine in '95, and then further scale up happened. And in 2020, we actually reached 5 megawatt capacity with the M20,000 unit. As for the isomill, there are a couple of benefits compared to other products from our competitors. As you can see, this isomill for regrind plants. On the left-hand side, you can see that there's an easily removable maintenance platform, and also a reduced footprint. And on the right-hand side, you can see how it compares to a vertical regrind mill. And actually, the footprint is very, very competitive and comparable with the vertical mill. And obviously, the height is way significantly smaller than that of a vertical mill. Back to the Jameson Concentrator. This is an example of this picture, what sort of footprint savings can be achieved. So this is a real plant, and an equivalent conventional concentrator is 3 times larger in footprint compared to a Jameson concentrator's footprint. Also, talking about the height savings can be also pretty significant for a Jameson concentrator compared to a conventional concentrator. This is a very interesting picture. As you can see, in this case, we managed to achieve 15 meters reduction in height and in the building. So that again comes back to a lot of savings in building costs. And now the OPEX savings. So the OPEX savings are mostly coming from power, maintenance, and some other factors. So in terms of power, yes, you might say that pumping requirements will likely increase, but that will be mostly offset by far with the following power savings. So these are the mechanical parts other than pump are not required. No agitators are required, no blowers and compressors. And typically there is, it means 30 to 60% reduction in power. As for maintenance, there are only 2 minor low-cost parts, and work can also be completed on the run, so reduced downtime requirements, reduced labor costs, and also reduced storage and holding capacity. That normally reflects in 20 to 50% reduction in maintenance. And also for plants that require indoor plants, so like Nordic countries, there is a reduced heating requirement, obviously coming from the reduced footprint and the building heights. As for the safety and the ESG benefits, less confined spaces and reduce height, improve safety of workers. Less power consumption, which is 40 to 60%, and reduce heating costs of indoor plants drive huge carbon footprint savings. Less moving parts mean significantly less spares to hold, much smaller stock holdings and warehousing requirements, alongside with less maintenance, transport, and logistic costs. Increased recovery of ultrafine particles can open new ways to reprocess all tailings and or recover more from the same ore. Another advantage of Jameson cells is that they scale up directly from lab scale dilution cleaning test results with high accuracy. So no need for scale-up factors. For difficult applications and or to mitigate technical risks, we have the Jameson Cell L150 test rig and the L500 test rig available for laboratory and site work respectively. Talking about the actual projects, the New Britannia Jameson Concentrator is up and running in Canada. This Jameson Concentrator offers 50% less footprint and power usage and exceeds upgrade ratios from the test results at high recovery. And in the footprint savings basically coming from that 4 Jameson cells replaced 12 tank cells. And yeah, on the right side, you can see that graph, and it's actually scaled up very nicely and actually providing a better upgrade ratio than the client experienced in the testing phase. In terms of ramp-up timeline, these two graphs show that the Jameson Concentrator almost reached 100% throughput gold and copper production within 6 months of operation, which is significantly better than the benchmark McNulty curves. So yeah, this is again doesn't need any explanation why it's so important. Another major lead and zinc project is also in the delivery phase. The customer is a lead and zinc miner, and the project location is in Northeast Asia. We're talking about a complex lead and zinc deposit, a bit about 6% zinc and a bit over 1% lead in the feed, and the throughput is 875 tons per hour. The plant is due to up and running in the next 2 years. And yeah, just a few words about how the Jameson Concentrator for this project compares to a conventional plant. So in this case, 19 Jameson cells replaces 63 tank cells. 3 new M20,000 isomills, each 5 megawatt, are also and will be also installed for this project. The footprint savings is over 50%. There's also reduced height and less heating, indoor heating. No air blowers are required, which means less noise and again power consumption. And it's safer, so less height and confined spaces. And we discussed that earlier, that significantly fewer spares are required. In Australia, we have 2 ongoing Jameson cell projects with Cadia. One is the expansion of the copper and gold flotation circuit, where we're putting in Newcrest putting in Z8500 12 downcomer cells for the big ones for rougher and rougher sculptor application. And these cells, as I already touched on this before, represent our latest development, and this is also a big step change in throughput compared to our previous cells. For the other project is the molybdenum circuit, where 6 the 6 downcomer E cells for used for the rougher application, and 2 1 downcomer Z cells for the cleaner application. And we decide, according to SIDE, the molybdenum circuit is achieving great target, which is really good news. Also, other Jameson cells are targeted for other nuclear operations because of the success. Talking about references, we have a large installed base of Jameson cells globally. So over 430 Jameson cells installed across 32 countries and many, many commodities. It is also important to mention that these cells are very well established in processing so-called clean energy metals such as copper and nickel. In fact, Jameson cells, most of the Jameson cells are used for copper in copper projects, which we know that it's one of the most important clean energy metals. A few words about the future. We also have a strong pipeline of projects. So a total of over 30 Jameson concentrators are considered for projects in the upcoming years. The throughput is anything from anything up to 120 million tons per annum. And the commodities that we are looking at are mostly, again, copper and other base metals projects, gold, copper projects, and a few platinum, graphite, rare earths, and even iron ore projects. And now a few words about how GT can assist across various project phases. So we can help across all the study phases from class 5 to class 1 and commissioning. It's important to note here that we can offer standalone, so basically studies that we can produce on our own. So we can offer class 5 and standalone class 4 studies, and basically there's a bit of a typical duration for a class 5. We would say 3 to 4 weeks, and for a class 4 it would be like 8 to 14 weeks. And also the costs are, we're talking about like anything from $7,000 to $15,000 for a class 5 study. It depends on if a 3D model is required by the client, then it would be probably more on the 15K mark. If it's not required, it would be probably on the around more closely to the 7K mark. For a class 4, we're looking at probably 50 to 75K, and we offer a lot with these studies. In a class 4, we offer a full study report with including mass balance, PFDs, a plot plan, and an equipment list. In the next step, we normally say that that's where we have our limit, and we were happy to actually assist the EPCM that's selected by the client, and from class 3 to commissioning, we're there to work with any EPCM that the client has selected. And just one thing is that Glencore technology aims to work with the EPCMs to provide the equipment, and that's it. So finally, I'd just like to summarize the key takeaways from this webinar. Safe, environmental and sustainable solution meeting the needs of the future we believe is the Jameson Concentrator. It offers reduced CapEx and OpEx for future projects. Also, there's a high circuit flexibility with the ability to easily flick between flow sheet configurations, very quick startups to achieve a steady state. That comes back to the low residence time requirements for Jameson cell and the fast kinetics. Again, we talked about the accelerated design with a one-to-one scale up from bench scale, from dilution cleaning test work to full scale, and also the high ability of the Jameson cells and the Jameson Concentrator to absorb ore feed variations. We also have a large installed base of Jameson cells globally across many commodities. And as we said, there's a strong interest for Jameson concentrators. Over 30 Jameson concentrators are considered for projects in the next 5 years. Later, I discussed about the HELP and the standalone Class 5 and Class 4 studies and estimates that we can provide in the early phases of project. And just to avoid any confusions, again, I'd like to reiterate that GT aims to work with the EPCM selected by the customer to provide the equipment, and that's it. I will now pass over to Glenn and Adam so they can answer some of your questions.
Thank you very much, Gabor, and thank you everyone for sending in your questions. As Glenn stated at the start of the webinar, obviously if we can't get to the questions today, we can come back and reply to you after the webinar. So there's been quite a number of questions actually come through in regards to particle sizing and recovery by particle size, what sort of benefits we can see there, and whether roughers and scavengers can collect the coarser material. So just to answer that question, I'll quickly share my screen so I can highlight a couple of occasions where we've completed size by recovery tests on site with Jameson cells. This first one's looking at the fines fractions, and it is specifically looking at a copper and gold operation. And as you can see, the recovery is really strong for the fines material. This is where the Jameson cell really comes into its own. As Gabor spoke about earlier, comes back to the really fine bubbles that are generated in the Jameson cell, the downcomer, and the ability of those fine bubbles to collect these really small particles. So all the way down to your minus C5 fractions, which is looking at your sub 5 micron particles. Recovery of target metals remains really strong. Another important thing you can see is the really low recovery of the NSG, so the non-sulfide gangue. And this is highlighting the benefits of the wash water, which you have the option to introduce to the Jameson cell, and really reducing that entrainment of fines, which you can see in a lot of other equipment. I'll then just refer to this second lot of data, which we took at a copper operation in Australia. And this showed the full broad range of the particle size by recovery in this particular operation with the Jameson cell. And as you can see there, it highlights very strong still at the fine recovery all the way down to the 3 and sub 3 micron range, but all the way up to the 300 to 400 micron range as well. So essentially the Jameson cell can perform as well, if not better, than your conventional mechanical cells with the coarser material. And then you get the added benefit of the boost of the improved fines recovery as well. So the rougher and scavenger stages, you would just manipulate your cell to make sure the parameters made sense for recovering the coarser material, higher airs, lower froth depths, lower wash water, and it would have no problems recovering these coarser material. I'll pass on to Glenn to answer another question.
Thanks, Adam. So I had a question regarding around rougher applications and Jameson cells in that area. So firstly, we do obviously have a number of Jameson cells that are operating in that area. As Gabor mentioned, there is the Cadia, the large 8500 cell that we're about to run at Cadia, which is in a copper gold application, very high tonnage. We obviously have the New Britannia full concentrator, which is also operating the entire circuit. So again, that will be as a rougher scavenger and into the cleaning side as well. We also have a number of other ones operating in gold applications around the world, as well as other copper ones. So there are numerous ones that we are operating very successfully as well. So I'll quickly just share a graph that just shows some of those examples. So the one to the right here, again, it's a gold application in a rougher cell. Now, what's quite interesting, this is a single Jameson cell operating ahead of a number of conventional scavengers behind. Now, this you can see the performance of the individual Jameson cell is extraordinarily high. This one cell has got a very high upgrade ratio from around 1 gram per ton all the way up to sort of around 40 to 60 grams per ton. So a very high upgrade, and also achieving sort of in the sort of 90 to 95% recovery range.
No sharing your graph.
Oh, sorry, I'm not. Sorry, everyone. I'll see where that stopped. Okay, sorry, I hope that's now sharing. So as I mentioned before, the table on the graph on the left-hand side, this is a gold application where you can see that the upgrade ratio is achieving very high from around a 1 gram per ton feed. And also the recovery is also extremely high for a single unit. So obviously the cells, tank cells behind this have very little work to do, considering a lot of the recovery from that single unit. And this is how we're able to sort of operate 2 Jameson cells as a rougher scavenger, because you can see what one cell can perform also at a very high upgrade. So the second cell behind it is doing very little. Essentially, it's just pulling what's left to grab. Also, something just of interest is the percent solids. In this example, you can see that this cell is also operating up to 45 to 50% solids and still achieving very high results. So again, it comes down to this may not be applicable to all applications to run this high density. And it comes down to a lot of it's around like viscosity and those sorts of things, which will be impacted by obviously the ore type mineralogy, but also how fine the feed is coming in. Looking to the graph to the right here, this is an example here where the Jameson cell, which you can see the sort of red and green across the top here, this is the grade recovery curve where that cell was operating. And across the bottom, these are the tank cells that were also operating within that exact same circuit. Jameson cell, again, is achieving around 5 times the upgrade compared to what the tank cells were achieving, which is also close to, well, it does actually exceed and reach the final concentrate target, which you can see at around about sort of 70% recovery. What is unique about that is it gives you the ability to scalp. And a few of you might know I suppose where Jameson sells a lot of installations in the scalping type of duty, because it does have the ability to operate at this very high end of the grade recovery curve. We can operate right down at the other end of the grade recovery curve by simply pulling extremely aggressively, but by having that ability to operate at a vast difference in terms of where you want to set it, it means your circuit can be really optimized and you can really target removing a huge amount of material that's already liberated. Shouldn't go through the regrind circuit, shouldn't go through the cleaning circuit. You should have a much more efficient, much smaller circuit as well. So a couple of examples here of very successful rough applications. So I'll hand it to yourself, Adam.
Yeah, thanks, Glenn. It's also been a few questions around Moly floatation. Moly's one of the really big areas, growth areas for the Jameson cell. We we tend to see really good performance with the Jameson cell operating on Moly. A key part of that is the general particle nature of Moly. So it tends to be sort of flaky particles, which can often want to flow with the natural movement within cells. So where it runs through cells which basically don't force that bubble particle interaction, it can often drift past and not see a bubble, whereas the Jameson cell going through that downcomer and everything moving through that lens, it's forced to interact with the bubbles, and we tend to get some really good recoveries results from that. So again, I'll just refer quickly to a slide which should hopefully give a good example of an example of the results that we've seen in the Moly industry. So this was a particular operation in South America where they wanted to see if they could increase both their copper and Moly recovery. So in their cleaner circuit, so look to introduce a cell on the tailings of their existing column cell. And you can see the improvement in the overall recovery, but even the comparison to the prior equipment, considering it was getting a tail and the previous equipment was removing the easily liberated, nice floating material, the recovery increase was really significant. So we've seen a lot of similar results like this on Moly, and it's definitely a growth industry for the Jameson cell. Okay, Glenn.
Okay, thanks, Adam. I have another question here, and Gabor touched on it briefly earlier, which was around the applications of the Jameson cell and some of the areas that it's operated in. I'll just dive a little bit deeper into that, just to give you an idea of some of the, let me just go to the screen. Yeah. And this time I will share my screen and not forget. Okay, so just a quick one here. This is just a quick snippet of some of the applications, well, basically all the applications that we're now working in. We have, as Gabor did mention, now over 430 sold and installed Jameson cells around the world. And this just gives you a quick snapshot of where we operate. And you can see there's very few areas that we're not operating. And a lot of these, well, most of these are all very successful and a lot of repeat installations. So yeah, we have that ability to operate essentially anywhere that a conventional cell will operate, essentially with air and any sort of conventional cell, that the Jameson cell will also operate very successfully in that. Typically, we hope usually better because of those things that we've talked about regarding the fine bubbles and just the setup and their high upgrade ratio that the Jameson cell can achieve. So I think what we might do now is pass back to Gabor. Any questions anyone else has, we're obviously happy to answer. Keep sending those questions through to that website and that email link.